In the previous video, we learned about line structures. These were really convenient ways of representing hydrocarbon compounds. Okay, so just as a quick reminder, let's go ahead and draw the line structure of this compound. All right, so what we want to notice here is that we have a core carbon chain of 1, 2, 3, 4, 5 carbons. So let's go ahead and draw that core chain. Here's carbon 1, 2, 3, 4, 5. Okay, we have all 5 carbons in that core chain. Now off carbon 3, which is our central carbon here, we have 2 more carbon-containing chains hanging off. Okay, the one going up is CH-CH2. Okay, and if you draw this out in a full Lewis structure, you'd see that's a double bond. So we have to have a double bond here, and then going down we have CCH, and that's actually a triple bond. So we show the triple bond like this. Okay, so now this line structure is much easier and much quicker to draw than the complete Lewis structure or the condensed structure, yet it communicates all the information that you need to know. So in this video, what we're going to focus on is how drawing these structures change if you have heteroatoms. So heteroatoms are any atom other than carbon and hydrogen, so anything except C and H. Okay, and the reality is that not much changes. Okay, the two things that you want to be aware of is that hydrogens on heteroatoms are always shown. Okay, and also heteroatoms are shown. Okay, so when we're dealing with hydrocarbon compounds that are functionalized with heteroatoms, then we show the hydrogens on that atom and we also show that atom. Let's see an example. So let's say we have ethanol, which is CH3, CH2, OH. All right, if we draw this out as a complete Lewis structure, this is what we see. So what you'll recognize here is that we do have a heteroatom. So this oxygen is a heteroatom, and this hydrogen is directly attached to the heteroatom. So we're going to show both of these atoms as well as the lone pairs on the line structure that includes this heteroatom. Okay, so in this case I have 2 carbons, single bond between those 2 carbons. So here's carbon 1, carbon 2, and now carbon 2 is attached to our heteroatom, which we are going to show. So we have oxygen and we have hydrogen, and we show lone pairs on heteroatoms. So this is a good line structure for ethanol, which is a hydrocarbon that's functionalized with a heteroatom. Let's try another one. Let's try this compound. We have CH3, CH2, N, CH, CH3. Okay, so we have a CH3 group attached to a CH2 group, attached to a nitrogen, attached to a CH, and CH3. Okay, so what I hope you can pick out here is that this carbon and this nitrogen don't have complete octets, so we need to have this double bond here. Okay, so now when we draw our line structure, not only do we need to very clearly show our heteroatom, but we also need to show this double bond. So I have carbon 1, 2, the third atom is a nitrogen, carbon 4, and carbon 5. So I have 1, 2, the third atom's a nitrogen, I have a double bond to the 4th carbon, now to the 5th carbon, and I need to show my lone pair. Okay, so this is a good line structure for this compound. What about converting a line structure with a heteroatom into a structural formula? So let's think about this compound. Okay, so this is an example of a fatty acid that we'll learn about in a few weeks. So what we can recognize here is that we have 1, 2, 3, 4, 5, 6, 7 carbons. Attached to carbon 7 are 2 heteroatoms, 2 oxygens. And between carbon 3 and carbon 4, we have a double bond. So this must be CH3, CH2. Okay, now carbon 3, we have a double bond. So we're going to have C double bonded to C. So to complete the octet here, I only need 1 hydrogen and 1 hydrogen. So that's carbon 4. Now to carbon 5, I have CH2. Carbon 6 is CH2. And now on carbon 7, I have a double bond to an oxygen and a single bond to this oxygen anion. Okay, so this would be the structural formula for this compound, this fatty acid. So in summary, drawing these line structures when heteroatoms are involved is not much more difficult. You just have to remember to always show heteroatoms and always show hydrogens directly attached to heteroatoms. Okay, and as with everything else, make sure you always show lone pairs.